Welcome to the webinar. We're excited today to be able to bring this webinar to you today. And so first off, we're just going to go through an overview. I'll be providing an introduction. Also, we'll go through what outreach technology is, followed by a presentation that Michael will be hosting. And he'll also go through some of the available technologies, and we'll also wrap it up with any questions that you've had and answering those. So in this webinar, we'll be exploring technologies that bring impact and stimulate growth of outreach ministries. Our focus has been to help our customers with technology that makes our lives better, and we continue that focus today in the face of adversity. What can harm us can also strengthen us. Today, we're going to look at how we can make our lives better where we are, as we are, and with the times as we see them progressing in the coming years. Today, we're going to explore outreach technology. What is outreach technology? Well, it's a vital part of any house of worship, as the Great Commission is to spread the word. Whether this is achieved by discipling people and sending them out, or by broadcasting your messages, there are technologies that can help you spread the word and stay connected to those within your circle. For a moment, imagine a world without the internet. Imagine a world without television or radio. Without technologies like radio, television, and internet, outreach ministries would look much like they did before these technologies existed. Today, we benefit from these technologies in our daily lives and harness them to enhance our outreach ministries. Some examples of outreach technology throughout the past decades include audio recordings, video recordings, podcasts, and of course, radio and TV broadcasts. Today's outreach ministries incorporate social media and live streaming, video prayer meetings, online teaching, and online youth events. Every few years, your outreach ministry grows in ways that were unimaginable before. This is partially due to continuous advancements in electronics and what we like to call outreach technology. And now, Michael, I'm going to call to you to continue on with the presentation.
Okay. Frank, can you hand control over to the, thank you. Just waiting for it to appear. Can everyone see my screen?
Yes.
Okay. So good afternoon, and thank you for attending this this webinar. First time I've worked with networks video, so I'm excited to assist them with Panasonic technology. So today we're going to talk about live streaming solutions from Panasonic for places of worship. Being able to deliver an immersive remote viewing experience for worshipers joining the service live and through on-demand video. From experience, this is something that was talked about quite a bit over the last few years, but it wasn't until the COVID-19 situation that things have really escalated and sped up. So we've been doing a lot of webinars over the last 4 months to various groups, just explaining how some of our products can be utilized in a live streaming workflow. Next slide. Just give me a second to advance. There we go. So some of the challenges, obviously, that have come up with the current situation is not being able to have an in-person service. You still need to create an atmosphere to engage the worship. Ability to deliver messages with high quality output. That's important because it does affect the engagement of the viewers. If it's poor quality, they will get disinterested very fast. Being able to operate a system from a non-dedicated AV department. Easy to use with flexible installation and simple connection to streaming sites. So these are some of the key challenges and concerns that we've heard about today. So benefits of investing in a broadcast solution as opposed to a webcam solution. So in the short term, we're able to extend the reach of your church beyond the local community, reaching out to those who are not able to attend in person, provide the opportunity to watch missed worships, and engage young people who use methods like social media, YouTube, etc., to on a pretty constant basis. That's how they get their news and their current events and talk to each other. So by investing in a broadcast solution for the short term, you're actually investing in a long-term investment, because I believe that once you've enabled the streaming capability, it's something that you will probably continue to use going forward. So essentially, this is a very simple drawing explaining the workflow for streaming. So obviously you need a video feed, you need a live streaming platform. So in the case of Panasonic, we have some cameras that actually have what's called RTMP and RTMPS, which is real-time media protocol, and the S is at the end is secure real-time media protocol. Facebook, YouTube, Twitch, Periscope. There's a number of services out there that support the RTMP, RTMPS stream. And the benefit of that, well, I'll explain in a future slide, but you're able to take a product from Panasonic that can actually support RTMP directly from the camera, and you can go directly to the site without any hardware in between other than a network connection. You can go into a live streaming platform using traditional baseband like HDMI or SDI, and then the live stream platform would then stream out to the streaming site of your choice. Here's some examples of some streaming providers: Sunday Stream, Daycast, StreamSpot, Boxcast. Depending on what your budget looks like, obviously with cost, you do want to make sure that it's as ad-free as possible, or that the ads that are coming up are not they're worship friendly. Being able to monitor what's happening real time. Archiving, so being able to archive what you've streamed automatically. Being able to stream to mobile devices as opposed to laptops or PCs or tablets. I guess tablets are mobile, but traditionally a phone. Audience analytics, if that's something that you're interested in, and then social media integration. So depending on which platform you use, would give you these types of features. Example from us on portable streaming cameras. So we have traditional ENG or electronic news gathering style cameras, as well as smaller handheld camcorder style for mobile use or low profile. So the larger ENG style has the ability to have interchangeable lenses. They give you flexibility with different shot options and camera placement. You can use the camera to roam in crowd. And then, as I mentioned, lens options in some where you can change the lenses and put a long or a wide angle lens on the camera. And we have in-camera recording. So we can stream and we could record in the camera at the same time. The second type of camera from us is a pan-tilt zoom robotic camera. So multiple cameras can be controlled remotely by one operator from a controller. They're very quiet. Most cases, nobody would really know they're there. And you can connect to them with an IP connection for control, streaming, and power. So you can run the camera from a single Ethernet cable. In a single camera application, this is typically what the setup would look like. So you would have a LAN connection from the camera to a computer. You could utilize auto tracking software, which I'll explain in a future slide. So you would have a GPU graphic processing unit installed into the PC. And the network connection is actually feeding image data back to the PC, and then it's sending control data back to the camera. From there, you could also have an SDI or HDMI output that could be connected to a recorder, a traditional DVD recorder or some sort of software recording system, as well connected to a monitor. This would be, this type of setup can be taken down and set up relatively fast. So if you have, mobile warships going on, you obviously want something that can be put into a case, small case, and then wheeled into wherever you need to set it up. Put them on tripods, and then run network cables from the camera to the recorders and start the production. Typical products that could be used in a single camera application. So as I mentioned, we have auto tracking software, pan tilt zoom control center software, which you can install on any PC and then control and see multiple cameras from one GUI. We have a number of pan tilt zooms that are used traditionally in these types of applications. So a single sensor camera, AWHE38 with 22 times optical zoom, the HE40s up to 30 times optical zoom, HE42 is 20 times optical zoom. These are all HD cameras. And then we move up to the AWUE70, which is a 4K single sensor camera with SDI and HDMI and 20 times optical zoom. And the HE130, which is a broadcast level HD camera with three sensors and HDMI and SDI built into the camera. These can all be connected by network to an RP60 controller to control and operate the camera. And you have an option to bring that into a production center if you want to add titling and special effects and transitions like an HLC 100. And also you could record on third-party software like Panopto, for example, which actually captures the IP stream coming from the camera. Another small space application was a camera called the UE4. This was introduced this year, so has a 111-degree viewing angle. It is 4K, but it allows you to do 4 times digital zoom down to 1920 by 1080 to give you almost like a pan and scan effect. So the camera itself does not move, but it does output streams over IP, can be connected to a controller or the PTZ control center software, and can be used in a smaller space like a classroom or something like that. And this camera has direct RTMP and RTSP streaming directly from the camera, or you can go, you can take the stream and then go directly into, something else over traditional H.264 type streaming. Live streaming in a multi-camera solution. Typically, when you have multiple cameras and you want to stream, it's better to take the cameras, feed them into a product like an AVHLC 100. This, like I said, allows you to add tiling and effects, do creative switching from one camera to another. It supports and stores camera presets, can do picture-in-picture. There's a multi-view monitor output for the operator. We have a preview and program output. So in the preview, you can actually create the title and add any effects that you want to, and then switch it to the program output, which is what the audience would see. So this does require an operator, and it's not extremely difficult. It does take some training and some experience to get used to it, but it is very easy to use once you set it up to your preference. We also have audio control, so we can actually bring audio in from an external audio board, or we can connect microphones to the individual cameras, and then that gets sent over the streaming, the network to the HLC 100, either through baseband, HDMI or SDI, or through NDI. And then we also have the ability to record the program output at the same time and stream to any custom site that you'd like. I'll talk about NDI in a future slide, but NDI is essentially a protocol, so it's network device interface protocol. Originally it was developed by a company called NewTek, and they still support it, but it's becoming a standard network protocol, plug-and-play protocol that could be utilized by a number of manufacturers. So any device that can deliver NDI or NDI-HX, any device that can receive that can see any device that's delivering NDI or NDI-HX. These typically in a multi-camera application, all the same cameras I mentioned before, but also in a larger venue, in a larger venue, you may want to move to a 4K camera with a lot of functionality with fiber output, 12 GSDI output, and 3 GSDI output. So the AWUE150 is a camera that we launched about a year ago, and it's become very popular in house of worship applications because of its picture quality. It is 4K, so it does give people the ability to purchase products now that may only be used in HD, but will be able to be used in the future when they want to produce 4K content. It also has a cropping mode where you can crop the image, so you can actually output the full 4K image from the camera in 4K or HD, but it'll also give you a crop area, which will allow you to actually get 2 shots from the same camera at the same time. It can be controlled from an RP60 or an RP150 controller. You can utilize it with the HLC100, and you can use capture software to capture the stream. As I mentioned, the HLC100 does capture the program output as well, but sometimes you may not use that, and you may want to use something that you already have or something that's more suitable to what you're doing. Another feature of our pan-tilt robotic cameras is the ability to install auto tracking software on a PC. So the auto tracking software has 2 features built into it. One is to be able to do face recognition or face matching. So you can load the faces of presenters like the minister in the software, and then enable the minister's face when he's there, and then the camera will actually follow him. So if you have a minister that likes to move around the stage or move around the front area of the church, the camera will follow them because it's looking for the face and it's matching. It can actually do matching up to 45 degrees off angle, and it will also recognize that if the priest turns around or the minister turns around, that that's still the same person. It's just that it's not able to see the face at that time. We've also included deep learning. So this is an artificial intelligence where we've loaded algorithms for human images and human body types, and the software will continually be able to track human faces and body just by the algorithms that are built in. By having the algorithms in the software already, we speed up the sampling by up to over 30 times per second. So the camera will never, very rarely lose the subject. A typical example of 2 types of setups for auto tracking. So we have a software that is a single license, so you can use 1 camera at a time to track. You install the software on a PC. The PC then would do the tracking. You could take the SDI output from the camera that would then be fed into an HLC100, for example, or into any live streaming platform. And then what happens is it automatically track and also send that stream out to wherever you want it to go. Another application using the auto tracking is taking the SDI and HDMI out and feeding it into a traditional recorder. So we're showing a Panasonic recorder here, but it can be anybody's recorder that can support an SDI input or HDMI input. You can also, we have a Wi-Fi app, so you can actually control the pan-tilt zoom from a tablet, as well as tracking as well. And like I said, we have a SF100, which is a single camera license, and then we also have a server license, which allows you to have 4 cameras active simultaneously on 1 server. Example of where we used it. So we did, it's not a house of worship event, but it is relevant because Cisco Live has their annual conference every year. Last year we had 70 of our 4K AWUE70 cameras with auto tracking enabled, which allowed them to have 1 operator responsible for 8 camera locations. The year previous, when they weren't using the auto tracking software, they actually had to have an operator for each individual camera. So with 70 cameras, they had to have 70 operators on site. With this system, they were able to reduce the operators down to 9. So each operator had a screen in front of them with 8 sessions of the auto tracking software open on the screen in front of them, and they were able to control and manage their locations individually. Here's our PTZ camera lineup, or robotic camera lineup. You'll hear it in the industry, so PTZ or PTZ, and some people call them robotics. So I like to just call them both. That way there's no confusion. So our AWUE150, as I mentioned, has a 1-inch 4K sensor. It's a 60p camera, has a 75-degree angle, viewing angle. Has a 12G, so it can actually send out 4K uncompressed over an SDI cable. It also has a 3G, which will allow you to send HD video over a SDI cable. You can send 4K or HD over HDMI. It has a fiber cage, so you can send uncompressed video over fiber, and it also has an IP output. All of these outputs can be output simultaneously from the camera at the same time. The next camera was the HE130, which is a 3MOS with 20 times optical zoom. This camera is actually going to be replaced in the fall by a new model called the AWUE100. It also will be 4K, and similar to the 150 with a smaller sensor, and it won't have the fiber out. It'll have 12G SDI and 3G SDI and HDMI and IP streaming. The new UE100 will also support SRT, which is secure, reliable transport streaming, and we'll be doing a webinar on that in the future just to talk about that technology. The UE70, as I mentioned, like was used in the Cisco event, is a 4K single MOS. It was the world's first 4K PTZ camera when it launched 4 or 5 years ago. Has 20 times optical zoom, hybrid image stabilization built in, as opposed to the 150 and the 130. They have optical image stabilizer. The hybrid stabilizer uses a little bit of optical and a little bit of digital to stabilize the image. HE42, which is new, that one again 20 times. It's an HD camera, has hybrid image stabilizer and a 3G SDI and HDMI output. And as I mentioned in the other slides, the HE38, the HE40, the UE4, and then we have an AWHR140. This camera can actually be used outdoors. So it's IP65, has salt resistance, has dynamic image stabilization. So it has a gyro and an optical image stabilizer built in for areas where you have a lot of movement. This camera, for example, is used on the Disney cruise ship to capture video from the live stage, outdoor stage on the deck. And the reason they chose this camera is because it is IP65 and salt resistant. But another key feature was the dynamic image stabilization system. So no matter what the ship is doing, if it's rolling side to side or if it's in heavy seas, the camera is actually able to stabilize for that shot. So the camera head itself will stay level while the body can actually move considerably. And it uses a 3MOS sensor as well and has a built-in wiper. On the camcorder lineup, so these cameras are typically used in a live event. So we have VariCam LT. So VariCam LT is actually a cinema camera. So it has a Super 35 sensor with an EF lens mount and can be optionally changed to a PL lens mount for cinema use. But we implemented firmware in this camera 2 years ago to actually allow you to use it in a live application. So we can connect this camera to a remote ROP or remote control panel, and we can have one remote control panel over Ethernet connect up to 99 VariCam LTs. So you can paint and shade this camera to so they all match in a multicam live event. The AJCX4000. So this is an ENG style broadcast camera, but it is a 4K camera with a 1-inch sensor. So as you notice, it will accept a 2/3 inch bayonet mount B4 lens. So if you already have invested in an HD 2/3 inch lens for a camera that you have today, you will be able to use that lens on the CX4000. It will accept it. So there's Panasonic built a magnifier that sits between the rear lens element and the sensor that allows the lens to fill the sensor on the CX4000. We've The VariCam LT has vlog built in, so you can record in a log gamma to give you a very wide dynamic range, which you can then take into a post-production workflow and apply any kind of look or color information that you want into the footage. So the CX4000 will also have vlog being added in future firmware update in the next few months, which will allow you to match a VariCam LT and a CX4000 together. Last year we introduced a camera called a CX350. So this camera actually has an integrated lens, but it gives you 20 times optical zoom. So the lens on this camera is equivalent in 35 millimeter terms, about 24.5 millimeters on the wide side to 490 millimeters on the telephoto side. So with this lens, it's going to reach probably 90% of your shot requirements that you might use in a camera with an interchangeable lens. So it does have a very long lens. It's light, it's small, it records on SD cards. So this camera has vlog as well, and it can stream. I forgot to mention that the CX4000 and the CX350, they have RTMP built in directly into the camera. So you can stream directly to YouTube and Facebook or any other RTMP site. We also have the ability to add an NDI license. Similar to the robotic PTZ cameras, we can add an NDI HX license, which allows us to actually stream to any NDI or NDI HX device that you might have over Ethernet, over an Ethernet cable, so you can stream to that equipment directly. And then the AG-CX10 is a new camera that we just introduced and should start shipping at the end of this month. It's the little brother of the CX350. Looks almost the same, but is smaller in size. It also has a built-in video light. The C350 has a 1-inch sensor. The CX10 has a 1/4-inch sensor. But low light, managing low light, both cameras are very capable. On the accessory side, we've got the RP150 controller I mentioned. This can connect up to 200 cameras. We have 10 camera selection buttons, and then 10 groups of 10, or 20 groups of 10 that you can select. So you can access all 200 cameras from this controller if they're all connected over network. It can be powered by PoE Plus, has a 7-inch touch panel, and if you're using the crop zone on a UE150, for example, it has some features in here to enhance that crop zone selection. The RP50, so this is now an RP60. So the picture we're seeing here is actually an RP60. It's similar to the RP150, but it has only a 5-inch screen, and it's not a touch screen. And in order to get to access some of the features like painting and shading, you need to drill down into some of the menus in the controller. But it is a very nice, small, compact controller. The HLC100, I'll talk about this in a future slide, because this is something that, as I mentioned earlier, is a production center that you can utilize to bring all your cameras to it and then output a program output that you would like to send, you would like to stream. We have an AWRM50, which is a little infrared remote control, like a television control, remote control. So you can actually connect up to 4 cameras and control up to 4 cameras in a space just by selecting the camera selection, and then you can pan, tilt, zoom, and focus each one of the cameras. The AWSF100 200 software, the auto tracking software, I mentioned that earlier as well, with deep learning body detection and face recognition. It says 30-day trial. We just extended the trial now to 90 days. So you can download the software and utilize Panasonic robotic cameras to actually use the auto tracking feature. The Pan Tilt Zoom Control Center software, this is free. And again, you can control multiple cameras. You can access presets, and like I said, it's designed only for Windows PCs, but it's free of charge. And lastly, we have a Pan Tilt Zoom virtual USB driver. So a lot of software programs, such as what we're using today, Zoom, Microsoft Teams, a lot of those applications, Skype for Business, they all work typically with USB cameras. So they expect that you have a camera connected to your PC just by a USB connection. What all of those cameras have in common and the software have in common is they're looking for what they call a UVC protocol, which is USB video camera protocol, which was developed years ago. And all the software in all PCs are set up to be looking for that UVC protocol. And when it recognizes it, if you go into your devices list on your PC, you will see a webcam as a device that you can then access through this type of program. So one of the problems was when you use the auto tracking software, you may have, which uses the IP stream from the camera, you may have a recording software that requires a USB camera. The cameras won't support USB connection and IP connection simultaneously at full resolution. So what our engineers did was they created a driver that you can install on any PC, and it will actually take the IP stream from our camera and then convert it to UVC protocol so that any computer will see it and recognize it as a USB camera that can be used with any software programs that you're using that use USB cameras. It's free. You can have actually 5 camera streams assigned per PC, and you're able to actually go in and select any resolution from the 4 streams that the cameras are capable of delivering. Third-party solutions. So we have there's a software out there that seems to be used quite extensively recently, and it's called OBS, or Open Broadcast Software. This is a free software that's developed by a community, so it's community developed software, and it has the ability to work with just about everybody's cameras out there. One of its features is that it does support NDI and NDI-HX protocol. It allows you to apply a lot of the same features you would see in a large production switcher, but it's all done on a PC. If you have, if your budget is constrained and you can't afford a production center like an HLC 100, this is an option. It is obviously a learning curve, and so somebody would need to understand and learn how to use this software, but it is an option out there. There's another software out there called vMix, which is utilized as well. I'm not as familiar with vMix as I am OBS, but definitely worth a try. Like I said, this doesn't cost anything, so it's not going to break your budget. Here's some examples of projects we've done. So with the VeriCam LT, as I mentioned, VeriCam Live, Christ Chapel Bible Church is utilizing 3 VeriCam LTs in a live production. And one of the benefits is having a camera like this is that you can have pan-tilt zoom cameras that are also in this application that can be permanently mounted. And then the VeriCam LT can be used on Sundays when you're having your services, but at the same time, you could use these cameras to record any type of content that you want for your websites, promotions, interviews, etc. So it's you get the best of both worlds because the camera can be used during the week for other applications and then also used for live production on the weekends. Another one is Hope City Church, also has 3 VeriCams. Same idea. This is a mobile, so they use actually a high school. So the church comes into the high school on the weekends. They set everything up. They do their services, and then they take everything down and come back the next week. So this being very a light camera, relatively speaking, it's around 6 pounds without the lens. The camera again can be mounted in various applications. Also, you can implement pan-tilt zoom robotic cameras into the mix. You could have a CX350 as well. There's lots of different ways of doing it. We actually, in Canada, we've got House of Worship in Montreal area. They bought 3 VeriCams last year with an RCP controller for doing multiple camera painting and shading. We've just sold 2 projects out west with 3 VeriCam LTs on each one. We've got another project that we're working on with some pan-tilt zoom cameras as well as some EVA1s. So there is a lot of applications using cinema style cameras and mixing them with pan-tilt zoom style cameras. So for example, as I mentioned, the Vericam LT, the EVA1, the CX4000 and the CX350 all support V-Log. We have a studio camera called the UC4000. It also supports V-Log. And then the AWUE150 pan-tilt zoom, it also supports V-Log. So all of those cameras can all be painted and shaded and matched. So on a production, they all look like they're coming from the same style of camera, but they're actually coming from 6 different types. From the Panasonic point of view, we created special pricing on our products. So we have a Panasonic support program for places of worship. One of the benefits of Panasonic Canada is that we still support sales, service, and warehousing in Canada. So out of our head office in Mississauga, we have a fully staffed service department. We have salespeople across Canada in remote offices, and we have our headquarters situated in Mississauga. So if you need to get a hold of somebody from service, there's always somebody available. We also have a very high reliability rate on our products. So our failure rates are typically below 1%. And that's not over a 1 year period, that's over a 3-year period that we measure that data. And then we have a 98% parts fill rate in Canada and our own warehouse. So if you match the last two items I just talked about, to have a 98% parts fill rate on a failure or repair rate over 1%, we would probably have to have a much larger warehouse. So having a low failure rate allows us to actually stock all the parts that we need to repair the product on site. So it's very important. A lot of other manufacturers are now supporting their products outside of Canada. So now we're into the question period.
And there were some questions that had been submitted.
Okay.
Just going to myself up. So we have a question. What are the hardware, software requirements for live streaming, as live streaming broadcasting would be new to our church?
Okay, so hopefully we answered some of those questions as we went through the presentation. But I mean, one of the hardware requirements, obviously, if you want to start to stream, is you need a camera. That's the basic feature. You also need some sort of audio. So typically, most churches already have an audio system in place. If you're using one camera placed at the back of the church to do a live stream, you could connect your audio system into the camera itself, and then you could stream from a simple application. You could stream RTMP, RTSP, or RTMPS directly out to Facebook, YouTube, any site that can support those protocols, and there's lots of them over the internet. So you just need to make sure you have a decent network connection that can support the bandwidth. Most cases, you're going to need at least the ability to be able to transmit 10 megabits per second or higher in order to have a good quality stream.
There was another question, and it's actually 3 questions in one. So, is there a piece of hardware that can grade cinematic cameras before they hit your video switcher? Also, cinematic or broadcast cameras, and why? And what are great wireless HDMI extenders for handheld shots?
Well, there's 3 questions in one. So I'll answer the first one. Typically in a cinematic camera, the ones that are created today, you have 2 options. So you can record in camera in V-Log, for example, like I mentioned, which is a very flat looking image, but it actually retains the entire dynamic range and color information that the camera is able to capture off the sensor. And then you can do one of two things. In a VariCam LT, for example, you can actually apply a lookup table, which gives you a unique look to the grade to the camera, to the image that's coming from the camera. And you can apply that lookup table only on the output. So you can still record on the internal cards the V-Log image, but you actually can deliver a graded image directly from the camera by just applying a lookup table. And the lookup tables can be standard like Rec 709, BT 2020, or we have a whole library of lookup tables that you can actually download for free. Install them on an SD card, and then you can apply that lookup table to the color grade directly from the camera. So in the case of the VariCam LT, it's capable of doing that. On a camera like the EVA1 or the CX4000, typically what you record is what you get. So if you're recording in V-Log, the camera is going to output V-Log. Or the other option is, on EVA1 you can record in V-Log and you can output a Rec 709 output. On the CX4000, you can record in V-Log and output HLG, or HDR, sorry. So you can output an HDR output or a Rec 709 output depending on where you're sending the content to. So that's that one. What was the next question in that series of three?
Cinematic or broadcast cameras, and why?
That's your choice. Some people prefer cinematic because you want to create that cinematic look, which is really popular today. One of the negatives of a cinema camera is because the sensor is so large, Super 35 or full frame, the cost of lenses goes up considerably, as well as choices go down as far as length. So it's very difficult to find a cinema lens that will give you a 20 times optical zoom or a 40 times optical zoom like you can get from a broadcast camera. So it depends on the application. And if you do find a lens that can do 20 times, like Canon has just released an EF lens that can do 20 times, but the cost on it is very, very expensive. It's actually about twice the price of the camera itself. So that's one of the negatives about a cinema camera. If you were to take a VariCam LT and put an EF lens on it, you are still limited. You do have longer lenses, but there's very few super wide angle. So if you want a super wide shot, it's tough to find a zoom lens that has a very wide angle and a very good telephoto on it. So you would have to move to a lens that you would interchange that had only one focal length. So you could put what we call like a prime lens, which has one focal length. And then when you need to do a long shot, you'd have to switch out the lens and put a long lens on. So it can be a little bit cumbersome. On a broadcast style camera, because it's 2/3 inch, you can get a lot more glass between the sensor and the outer element, which allows you to actually have a lens that can do 20 times, 30 times, 40 times, 100 times. There's a lot more options out there. What was the next one?
What are great wireless HDMI extenders for handheld shots?
We don't make any. So, there's lots of HDMI extenders out there on the market. There's product by Teradek, which will allow that they use on production sets, on cinema production sets, so they can actually mount the transmitter on the camera and the receiver elsewhere in the video village, for example. So Teradek is one. There's a number of companies out there. I'm not going to recommend one over the other, so I would just suggest doing some research and also working with networks, AV, and they could probably provide some solutions for you. Okay.
Okay, so Frank, were there any questions that came up in the Q&A or the chat?
Yep, we currently have 3. What is the realistic distance from a camera at the back to a subject at the front of a venue, or of a church, I imagine?
You mean as far as being how much of the, I guess, okay. So we do have a lens calculator that we produce, and let me just see if I can get that on here. But it will it's the calculator is created for all of our all the cameras that we make. So I'm just going to run a number here for you just to give you some idea. As soon as I find the find it. Just unshare my screen for a second. Just bear with me for a second while I find it here. So as I was mentioning, we do have a calculator that we created, and all you need to do is plug in the number, the distance, and it will actually give you the image size based on wide or in zoom. So here it is, and pull up the screen. So this is the image, this is the calculator here. So down and below, you would select the camera that you're using. So let's say we're going to use an HE40, which has a 61-degree viewing angle on the wide side. So if I say let's say we have some numbers that are in here, I can change these on the fly, and we can make this available. Let's say I'm going to say my distance is 75 feet. So I'm now 75 feet from the back of the church to the podium area. In full wide angle, I'm going to see a field of view of 89 feet wide by 50 feet high. Now, if I zoom the camera in and plug that same number in of 75, doesn't matter where I put it, I can see an image that is 2.75 feet wide by 1.54 feet wide. So this is a camera that has 30 times optical zoom. If I go to a camera that has 20 times optical zoom and do the same calculation, so again, 75, 95 by 53, so 95 feet wide by 53 feet high, down to 4.27 feet by 2.40 feet. So even at 20 times optical zoom, you can get quite a small image from a 75-foot distance. So it does give you quite a bit of versatility from the camera. We have the same calculations available for a camera with a 2/3 inch sensor, like the CX4000. And if I were to put a 34 times zoom lens on the camera, and this is probably in meters. Yeah, this one's in meters. So 34 times, and let's say I'm 20 meters away, which is about 65 feet. I can get an image down to 3.18 inches by 5.65 inches. So you do have quite a bit of flexibility with those types of cameras. Okay.
Okay, next question. You'd answered one that was submitted earlier. So thanks for answering our earlier question. One of the necessary components of the live streaming for us is to provide lower thirds words for lyrics and readings. How would you integrate the component into the live streaming system?
So lower thirds for
words,
yeah,
for lyrics and readings.
Words, lyrics, and reading. Okay. So we have downstream keyers in some of our products. It might have a slide here of a product. So this is the HLC 100 I was talking about earlier. So this is a production center. So this allows me to bring, it has 8 input, it's an 8 input video switcher production unit. It can support NDI, SDI, and HDMI. So it has eight inputs. 4 of those inputs are baseband. So you can have input 1 is shared between SDI and HDMI. So you choose either an HDMI or an SDI input. And then inputs 2, 3, and 4 are traditional SDI. And then the other 4 can be NDI or NDI-HX, or all the inputs can be NDI or NDI-HX. And then what happens is they have the ability to create titling. So we have some preset titling built into the unit, that can then, you can apply titles. So you could set it up so you could actually be switching the title slides in real time with an operator. So we have presets that you can actually set up in the controller that you can then call title, and then you can actually call up to 8 different title presets, which could have verses into it. There is the ability to bring picture-in-picture, which could be placed in the lower 2/3. So if you have a PC that's actually feeding in through the HDMI input, or if you were using an NDI source, like Microsoft Teams, for example, is now going to be supporting NDI. There's a software application called ProPresenter, which is used quite a bit by a lot of churches. That basically brings a feed in from a PC, so that can be overlaid into the same image as the live image that you're bringing from the camera, and that could actually provide the lower 2/3 information that you're looking for. So yes, it's possible with this type of a product. This product also supports pan-tilt zoom control, so it has a controller built into it, so you don't need to buy a Panasonic controller. You can use this. It has the ability to output to various streaming sites and multiple sites simultaneously. So you can go to YouTube, Facebook, you know, Microsoft Teams is going to support streaming as well. So we could stream into this over NDI and stream out to back out to Microsoft Teams, which would then be streamed out to any other live event. There's about 50 to 60 manufacturers today that are supporting the NDI protocol, and it's growing. As I mentioned, Microsoft is now supporting it with Skype and Teams. This unit also supports Skype TX, so you can bring a Skype TX from a separate PC and feed it over the IP connection into this unit, so you can actually receive remote calls over Skype into this unit. From what I understand from Microsoft Teams, each person that's logged into Microsoft Teams, you can create an individual NDI stream for each one of those, so that you can then have 8 people as inputs on the HLC 100 and apply titling. All of this is possible, so there's a lot of flexibility with a product like this. We have the access to pre-recorded clips, so there's an internal hard drive as well as a USB, 4 USB ports that you can connect external hard drives to. It is connected to the network, so it could actually be connected to a network drive also. And we can call up those pre-recorded clips. We've got still images. They can be used as picture-in-picture or full images. We can apply titles. We also have internal recording inside the unit, or we can again record onto an external hard drive. And let's say you're doing a mobile application, you don't have a decent network, but you can still record the entire session and then put it on your website and then broadcast it later. So it's a very flexible product for that application. I didn't have time to put this in the presentation, but we recently launched a free app on Android and iPhone, and it's called Cam Control. But it has capability of actually applying titling to pan-tilt zooms and then streaming that out to Facebook and YouTube as well. Next question.
Yep. What is a minimum system, as in how many cameras, type, etc., and what is the suggested broadband bandwidth?
Minimum system could be down to 1 camera. The bandwidth is typically, if you're using NDI-HX protocol, it requires 24 megabits from each camera. So normally, if you were using an HLC 100, for example, you would create an internal network within the facility, which essentially you put a 1 gig switcher on there, and you have the ability to connect up to 8 cameras, and you have all the bandwidth that you need. On the outgoing side, you're going to need at least, as I mentioned, you're going to need to have a high-speed network that can support at least 4 to 10 megabits per second for an adequate, decent stream. Anything below that, and you're going to, the quality is going to be inferior. And you spend all the money on better cameras, but now what your viewers are seeing is an inferior product. So it's always recommended to have a better, higher bandwidth as possible. There's fiber is making it out to locations a lot more than it used to, so you can get some fairly robust network connections now.
Okay, Mike, the final question. Is Panopto or OBS something to be used instead of HLC 100 or in addition to it?
Panopto, these would be used instead of HLC 100. So OBS is essentially a PC-based system, so everything's installed on a PC. There is quite a bit of a learning curve, and there's a lot of programming involved. So it's not for the faint of heart when it comes to being technical. It does require a lot of technical savvy to understand exactly how to get it set up properly. And it is, you're at the whims of Microsoft as they change, come up with firmware updates and those types of things. It can cause compatibility issues. So taking a product like an HLC 100 that's developed by Panasonic, we manage the software, we manage the firmware in our cameras. The whole idea is that this ensures that you do have compatibility all of the time. So you don't have to wait for a firmware update because we changed our camera firmware, but we have to wait for OBS to change their firmware to support that feature. So now nothing works. So that's one of the benefits of a hardware solution versus a pure software solution, is that being able to synchronize product updates to make sure everything works all the time. Okay.
And that was the final question.
Okay. Well, look at that. 2 minutes to spare, 1 minute to spare. Okay. Well, thank you very much. Did you have anything else you wanted to say?
I just want to say thank you all. Thank you, Michael. Thank you, Frank, for putting this together for us so that we could learn, what is available from Panasonic. And really, we're thankful for this. Thank you very much.
We covered a lot in a short period of time, so we can tailor some of these down to be more product specific as the requests come up. So feel free to send the request to James, and we can try to maybe tailor some webinars that are a little bit more specific.
And we thank you all for joining us.
Bye for now.